In this video, we will learn about very important concept of class 12th, which is matrix. Now, the name of the chapter is matrices. So, first of all, let's understand what do we mean by a matrix. So, suppose I write something like this. We have often seen this thing written, or we have seen when we were in primary classes, we have seen something like this. So what are these? I am writing something in rows, something in column. The basic arrangement of writing anything in rows and columns is known as matrix. So what is a matrix? We say it is a rectangular array of some numbers which are arranged in rows and columns. So horizontal are rows and vertical are columns. So when we write something horizontally, we say it is rows. So this matrix has 3 rows and 3 columns. So we say the order of the matrix is 3 cross 3, where this is row and this is column. We always write row first and then we write the column. So what is the order of a matrix? Number of rows multiplied by number of columns. If I multiply these two, the answer that I get is the number of elements in the particular matrix. So number of elements in this matrix are 9. So what is a matrix? Simply a rectangular arrangement. Do remember the underlining word, that is arrangement. So over here we represent matrix mostly by this or these type of brackets you will find in book. Now, how do we locate? How do we describe a particular matrix? So suppose I have a matrix like this. We write the elements like this. Now, what does it mean writing the elements like this? Suppose I have written a matrix of order 2 cross 3, let's say. So we write it like this. When I say A11, what does it mean? It means the element present at first row and first column. That is this particular element. So when I write A12, it means the element present at first row and second column. Similarly, it goes on. So suppose we have the general representation of matrix. For matrix, mostly we use capital letters whenever we have to represent a matrix, and when we write elements, we use small letters. Suppose in general, we write matrix as Aij m cross n, where Aij means ith row, jth column element, and m cross n means the number of rows and number of columns. So we often get questions in the exam like where we have to describe, let's say, a 2 cross 3 matrix such that Aij is equal to I upon j. So this type of matrix, if we have to describe, how we will do a question based on this. So 2 cross 3 matrix will be this matrix only. So for A11, what will I write? I will say A11 in place of I, in place of j. Both places I will write 1, 1. So I will write 1 upon 1, that is 1. Similarly, if it is A12, I will write in place of I1 in place of J2, so it is 1 by 2. So we will keep on writing that particular answer over here. This is 1, this is 1 by 2. Similarly, for A13, it will be 1 upon 3. So I will write 1 upon 3 over here. And similarly, for A21, it will be 2 upon 1. So I will write 2 over here. For A22, it is 2 by 2, so I will write 2 over there. For A23, it is 2 by 3, so I will write 2 by 3 over here. So this is my matrix, which is a 2 cross 3 matrix, which is given by this particular formula. Similarly, in NCERT first exercise, you will find many questions based on this. So you have to try all those questions which are exactly based on this particular line. And we have sometimes one more question. Suppose a matrix is given, the question says what is the element, let's say A22. So given this matrix, A22 means the element at this particular position. So you will locate second row, second column. So over here it is 5. So we have to write those particular elements, randomly pick the elements, and then we have to locate their position according to first row and then the second column. Okay, now next what we will do, we will do the types of matrices. Next we have types of matrices. So as you can see, we have types of matrices. I have written over here. So first is row matrix. So what do we mean by a row matrix? When we have a matrix, if I say my matrix is written like this, I have one row and I can have any number of columns. Then that matrix is known as row matrix. Now column matrix, similarly if I write all the elements in terms of column, I can have many rows, but I have only one column, then I say it is a column matrix. Next we have zero matrix. What is a zero matrix? When all the elements of the matrix are zero, then we say it is a zero matrix. Next we have a square matrix. So what is a square matrix? If I say the number of rows and number of columns are equal, the matrix becomes a square matrix. That is a square matrix. Suppose I write over here like 3, 1, 2, minus 1, 0, 1, 1, 2, 3. Then this is a, you can observe 3 rows and 3 columns. So this is a square matrix. So further we have for square matrix classification, we have for square matrix, first is diagonal matrix. So when we have a diagonal matrix, what does it mean? First of all, let's understand, before going to diagonal matrix, we should know what are diagonal elements. So what are diagonal elements? The elements such that A11, A22, A33, where these I and J are same, we say they are diagonal elements. So over here, these are diagonal elements because over here, the number of rows and the number of a column is same. So if the diagonal elements are any, let's say these, and the rest of the elements are 0, we say that is a diagonal matrix. Very important, a square matrix is diagonal if the diagonal elements can be any element and the rest of the elements are 0. Next from diagonal we have scalar matrix. So what is a scalar matrix? When the diagonal elements are same and the rest of the elements are 0. Diagonal elements are same means all the elements should be exactly same. From scalar, we move on to identity matrix or unit matrix. We say a matrix is identity or unit matrix when the diagonal elements are 1 and the rest of the elements are 0. So from these two, diagonal, scalar, identity, we can say identity matrix is a scalar and diagonal, but why? So what we know now that all identity matrices are diagonal matrices and scalar matrix. All scalar matrix can be diagonal matrices, but vice versa is not true. And also one more important thing, that if we have one matrix, we say it is a matrix. The plural for matrix becomes matrices. Next what we will learn is, we will learn question number 2 and 3 of exercise 3.1 NCERT, that how if it is given that the number of elements in a particular matrix, suppose it says the number of elements are 24, then how can we decide the order of that particular matrix? So to decide the order of the particular matrix, we will write the factors of 24 that we used to do. Like this, we will move in order. So it will be like this. So what are all possible orders that can be there? 1 into 24 and 24 into 1. Similarly 2 into 12 and 12 into 2. 3 into 8 and 8 into 3. 4 into 6 and 6 into 4. So these are the possible orders. So given a number, what you are supposed to do? You are supposed to write the factors of that particular number. Suppose I have a prime number, let's say 13. So I can write again its factors. For a prime number, only 2 factors are possible. So we will have 2 orders. So in general, we can say if P is prime number, then the possible orders of the matrix can be 1 cross P and P cross 1. Next, we have a very important question, that is almost the last question. The rest of the questions are based on the concept that we have discussed so far on the basis of comparable matrices, and when Aij is given, you have to construct a matrix. So what is this question? It says, what is the number of all possible matrices of order 3 cross 3? How many 3 cross 3 matrices can I construct when each entry is either 0 or 1? So what can be the answer for this? So what is matrix? Matrix is simply an arrangement. So if it is an arrangement, 3 cross 3 means I will have 9 places to fill with 2 options. So this can be filled in how many ways? 2 into 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 2. That is 2 ki power 9 ways. The way we used to do the permutation. So we have 9 places, 2 options. Each and every place can be filled in 2 ways. So we have to multiply it 9 times. So that is why it is 2 ki power 9. Right? Now next what we will do? We will do the operations on matrices. So what are the operations that are possible on matrices? The first operation is addition. How do I know can I add two matrices or not? Or can I subtract two matrices or not? So we will do addition and subtraction together. So when can we add two matrices? When they have same order. I can subtract and add two matrices only when they have same order. Suppose I have 1, 2, 3, 4. Let's say I cannot add 2, 1, 2, 8. This is not possible because these two do not have same order. I can add two matrices only when they have same order. So this can be added to this matrix because the order for both is same. Why? Subtracted also. Why? Because to add and subtract I need corresponding elements, and it is possible only when I have same order. So if I add, I'll add it like this, corresponding element wise, 3 plus 4, 4 plus 2, and if I subtract, I'll subtract it like this, 2 minus 2, 3 minus 4 and 4 minus 2. So this is addition, this is subtraction. We will solve the answer and write it in the form of matrix. So it is like this for addition, and for subtraction it is this. So when we see this addition and subtraction, addition we can say that addition is commutative, because if I add a plus b, this plus this or this plus this, I'll get the same answer. But subtraction will not be commutative because in general also subtraction is non-commutative, right? So addition is commutative, subtraction is not. Next operation we have is multiplication by a scalar. So what is a scalar first of all? Scalar can be any constant, any number for that matter, which keeps on changing. That is why we say it is a scalar. It can be any number. So if I say I have a matrix and I have to multiply it by 4. So how will I multiply? I will multiply each and every element of the matrix by 4. So if I multiply it like this, this is known as scalar multiplication of a matrix with a scalar, or scalar multiplication in general. Do remember, each and every element of the matrix is multiplied by that particular k, right? Next, what do we have? Based on these, we will have questions in exercise 3.2 where we have two matrices will be given, three matrices will be given. We have to add, subtract, and we have to solve. Now next what we have to learn is multiplication of two matrices. So how can we multiply two matrices? So let's see how can we multiply two matrices. First of all, if we have to multiply two matrices, what we have to remember? If we have to multiply two matrices, what we have to remember that first of all, if I have a matrix like this, let's say this, and I have a matrix like this, how will I check that these two matrices can be multiplied or not? What is the compatibility point that we have to check? So first matrix, what is the order of this matrix? Let's say order of this matrix, it is 1 cross 3. What is the order of this matrix? It is 3 cross 2. The number of columns of first should be equal to the number of rows of the second, then only two matrices can be multiplied. So over here I can multiply these two. What we have to remember, the number of rows is equal to the number of columns is equal to the number of rows of the second. So whatever you write first will become first, whatever you write at the second place will become the second. Now how do we multiply? We multiply the row with the column. If I have one row, I'll multiply one row with first column first, and then I'll multiply the first row with the second column, right? Now, what will be the order of the product matrix? So, order of product matrix. What will be the order of product matrix? I'll cut these two. This is 1 cross 2. So, we will cut the number of column, whatever is same, that is number of column and number of row is same. We don't have to see that. Now, what is left? The number of row of first and the number of column of the second. The product of those two, that is 1 cross 2, will be the order of the product matrix. So this type of question is generally asked as 1 marker in exam, where it is written without actually multiplying, and also the elements are not given. If order of 1 is given and order of second matrix is given, what you have to do is you have to find the order of the product matrix. So this is how you can find the order of the product matrix. Now let's see how do we multiply. So I'll do it over here. How do we multiply? We'll multiply first row with the first column, corresponding element wise, and putting plus sign in between. So how do we do that? So it is 1 into 2 plus 2 into 4 plus 3 into 5. So that will become my first column. So what I will do, I will multiply first element of first row, that is 1, by the first element of first column, that is 2. Then 2 with 4 and then 3 with 5. Similarly, now what I will do, I will multiply 1 with 6, 2 with 7 and 3 with 8 and write it as column 2. So I will multiply 1 with 6 plus 2 with 7 plus 3 with 8. Over here, what do we observe? The order of the product matrix is 1 cross 2. So what will be my answer? So it is 2 plus 4 to 8 plus 5 3 15. This is 6 plus 14 plus 24. So let's add it up quickly. This will be 25 and over here this is 44. Right? So this is the product of two matrices. We will do some more questions based on this. Let's see some more examples. This is question number 3 of exercise 3.2. 1 and 2 are based on the addition and subtraction, which everybody can try. So what is this particular question? What we have to do? We have to multiply these two matrices. So first of all, what we have to check? What is the order of this matrix? 2 cross 2. What is the order of this matrix? It is 2 cross 3. So I can multiply because the number of columns and number of rows are same. So right, what will be the order of product matrix? Order of product matrix will be 2 cross 3, the left out thing. Right? Now how do we multiply? We will multiply row with column. First row with first column, then first row with second column, then first row with third column. So I have made it different using different colors so that you can understand. Now how do we multiply? So let's start. So first of all, what I'll do is I'll write 1 with 1, 1 into 1 plus minus 2 with 2. First element with first element, second element with second element. So at first place. Then first element with the first element of second row, then second element with second element of second column. Right? Then similarly first element of first row and first element of third column, then second element into second element. Right? Now let's move on to the next row, which is 2 and 3. So now what we will do again? We will multiply the first element of second row, that is 2 with 1, then plus 3 with 2. So first element with first element, second element with second element. Then further 2 with 2 plus 3 with 3. Then further 2 with 3 plus 3 with 1. So first element with the first element, second element with the second element. Right? This is how we will multiply. Now let's quickly solve it up. What we will get? So it is 1 minus 4, that is 3, minus 3, 1 minus 4, then 2 plus 6, 8, this is 2 minus 6, that is minus 4, 4 plus 9 will give you 13, 3 minus 2 will give you 1, 6 plus 3 will give you 9. So this is your product matrix. Right? Now next question, same question, next part. What we have? What type of matrix is this? This is 3 cross 1. And what is this? This is 1 cross 3. So what this is multiplicable. And what will be the order of the product matrix? It is 3 cross 3. Observe very carefully. So how do we multiply? This is a question where most of the students do mistake. So what do we do? First row with first column. So only one element is there in both, so we don't have to add up anything. Right? So what I'll do, I'll just write 1 into 2 for first, then 1 into 3 for second, 1 into 4 for third. First row, first column, second row, first row, first column, first row, second column, first row, third column. Then 2 with 2, then 2 with 3, then 2 with 4, then 3 with 2, 3 with 3 and 3 with 4. Let's write the answer. So 2, 4, 6. 3, 6, 9, 4, 8, 12. So this is your product matrix, right? Now let's move on to the next question. So what do we have? Next question is, we have next part, we have 2, 3, 4. We will quickly do some questions so that the concept is very clear to everyone. The rest of the questions you are supposed to practice, and then only you will be able to master this particular concept of multiplication. We don't have to show this thing in exam. We can directly write the answer, no problem. So again, what do we have? What do we observe? We have first row, first column. So I'll just multiply, quickly check. This is 3 cross 3. This is 3 cross 3. So again, the order of the product matrix will be 3 cross 3. So lengthy question. So let's do it quickly. So 2 with 1 is 2 into 1 plus 3 into 0 plus 4 into 3. First row, first column. First row, second column. 2 into minus 3 plus 3 into 2 plus 4 into 0. Then first row, third column. So it is 2 into 5 plus 3 into 4 plus 4 into 5. Right? Now second row, first column. So it is 3 into 1 plus 4 into 0 plus 5 into 3. Then second row, second column. 3 into minus 3 plus 4 into 2 plus 5 into 0. Right? Then second row, third column. So it is 3 into 5 plus 4 into 4 plus 5 into 5. Right? The next third row, first column. 4 into 1 plus 5 into 0 plus 6 into 3. Right? You can do it together. Let's do it together. Okay, now next, the third row, second column. 4 into minus 3 plus 5 into 2 plus 6 into 0. Then next, 4 into 5 plus 5 into 4 plus 6 into 5. So we have all the elements over here. Let's quickly solve it up and see what we are getting. Finally, the concept will be clear. So 2 plus 0 plus 12. So 14. Then 3 plus 0 plus 15, 18. 4 plus 0 plus 18, 22. Right? Then next, minus 6 plus 6. So everything will get cancelled, 0. Minus 9 plus 8. So it is minus 1. Minus 12 plus 10. So it is minus 2. Over here, 10 plus 12 plus 20. It will be 42. Then 15 plus 16 plus 25. It will be 56. Then 20 plus 20 plus 30, it will be 70, right? So this is the product matrix 3 cross 3. I hope now multiplication is clear. Based on this, all the questions of the exercise can be done, right?